Solving a system of nonlinear equations. So remember, a system of equations is simply more than one equation. These are nonlinear because the x here has an exponent of 2 and the y has an exponent of 2 as well. Okay, so linear usually would resemble an exponent of 1. These are definitely nonlinear equations because the exponents actually exceed 1. Just to give you a little bit of a background here, what are these equations really talking about? These are actually from a topic called conic sections, and conic sections is often used in the study of orbits in astronomy. For instance, this first one here is representing some kind of elliptical orbit, and if I had to draw it, it could be resembling a elliptical orbit of a planet. And then the second conic section there, let me point back to it. The second conic section here is not an elliptical or oval orbit. In fact, it's more like an orbit of a comet. And so I'm going to draw one branch of this conic section. It's just going to be a quick sketch. It's not going to be an accurate drawing, but this one could look something like this. And so you could have a comet sort of flying in this direction from left to right, going like that. And then on the other hand, if you take trigonometry, you could have an orbit of a planet going this way. And of course, what are astronomers curious about? They're going to be curious about if this comet ever hits the planet itself. Okay, so that's just a little bit of background on what some of these equations are actually representing. Let's go ahead and solve this system. There's definitely a couple different ways to do it. I'm going to do a substitution method. So first thing I'm going to do is label the first equation 1 and the second equation 2. I'm going to rewrite equation 2 by solving for x squared. X squared is now equal to 4y squared minus 10. I'm going to take this equation and substitute into 1. Substitute into 1. So into equation 1. So whenever I see an x squared, I'm going to put parentheses 4y squared minus 10. Parentheses 4y squared minus 10. And then plus y squared is now equal to 9. Now this looks like an algebra problem that you could react to, and of course we're going to try to solve for y. 12y squared minus 30 plus a y squared is now equal to 9. We have 13y squared is equal to 39, and divide the entire sides by 13 because 13 is not 0, and we get y squared is equal to 3. I'm going to try to solve for y. So square root of y squared is equal to now square root of 3, square root of both sides. But remember, the square root of y squared is really what? That's just the absolute value of y. And the absolute value of y is equal to the square root of 3. Now we know how to solve this. Y is equal to positive square root of 3, or y is equal to negative square root of 3. So we have two cases. Case 1. What happens when y is equal to the square root of 3? We want to find x. So which equation are we going to use here to find x? Why don't we use this one? In fact, why don't we use that one? And we're going to solve for x. So x squared is equal to 4. Whenever you see a y, you're going to put parentheses square root of 3 squared and then subtract 10. So x squared is equal to 2. And once again, we take the square root of both sides of this equation. We get the absolute value of x is now equal to the square root of 2. X is equal to positive root 2, or what? X is equal to negative root 2. So that satisfies case 1. Why don't we write our ordered pairs for case 1? Remember, the y is the second part of the ordered pair. So there's one ordered pair. Another ordered pair is what? Negative root 2 and then root 3. Okay. Now we're going to do case 2. Let's do case 2. What is case 2? Case 2 is y is equal to the opposite of the square root of 3. Once again, we're going to use that equation that I mentioned earlier. Whenever you see y, you're going to put parentheses, negative square root of 3 squared minus 10. Notice this algebra is going to look exactly the same as on the left. So I don't really have to write much. So we have what? X is once again square root of 2, or x is equal to negative root 2. So let's write our ordered pairs for case 2. We also have root 2, negative root 3, comma here, and then I guess I could put a comma there. Then we also have negative root 2, negative root 3. Okay. Now this doesn't quite match the picture up there, and that is because I didn't show you guys that other possibility of the hyperbola. You could have another orbit down here representing a different comet. So intuitively, what's going on is you're finding points of intersection like that. So that's why we have 4 answers. Why don't we circle this, or at least put an oval around our summary. There it is. That is your final answer, but be sure to show all your work as well. So and try to keep things as organized and as neat as possible. So I'm going to go ahead and circle the artwork that is on this board right here.